So for this section, we're going to look at scale diagrams again, but this time we're going to look at reductions. So this is an example where the image is much smaller than real life. And one of the most common reduction is a map, because obviously the image is much, much smaller than what is being represented. So let's take a look at an example here. I have a little clipping from Google Maps, and we can see part of Vancouver. And I've used the tool on Google Maps to measure the distance between 33rd Avenue and 41st Avenue. And hopefully you can see that it comes out to pretty much exactly 840 meters. So that's the measurement in real life. On the map, now of course this is going to be totally different on your screen because it'll be a different size, and even if you printed it out, who knows what it would end up looking like. But I took a ruler and measured the distance on my screen, and the distance on my screen between 33rd and 41st was 7.5 centimeters. And again, in real life, that was about 840 meters. So let's try to figure out the scale for this map. So the scale, again, you start with the image. So in this case, that's the 7.5 centimeters. The image is the map. So we have 7.5 to the distance in real life. But here's where we have to be very careful. The distance has to be expressed in the same unit. So we have to take 840 meters and convert that to centimeters. And the conversion is simple. It's just multiply by 100. So we end up with 84,000 centimeters. And that's our scale, 7.5 to 84,000. But as I mentioned in the last video, typically with a scale, you will divide both sides by the smaller number so that you end up with one of the numbers being 1. So if we divide both sides by 7.5, we end up with 1 to 11,200. And you can see that, that gives you a fair bit of detail for a map, 1 to 11,200. If you were looking at a map of the whole of the Lower Mainland, it might be something like 1 to 20,000 or even 1 to 50,000. And if you're looking at a map of the entire country, you might be looking at a map of like 1 to 1 million or 1 to 2 million. So 1 to 11,000 gives you pretty good resolution. Now, of course, we can also talk about a scale factor. Quite frankly, with this sort of reduction, we generally just deal with the scale. We don't really talk about the scale factor too much. But again, scale factor is easy to find if you know the scale, because converting from a ratio to a fraction, you just take the number on the left, that becomes your numerator, and the number on the right becomes your denominator. So your scale factor here is 1 over 11,200. Now keep in mind what that means. That means that a measurement in real life can be multiplied by 1 over 11,200 to create the measurement on the map or the measurement on the image. But we're usually going to be going in the opposite direction. We're usually going to be looking at a map, measuring a particular distance, and then using that to find how far it is in real life. So in that case, there's a little bit of an equation that you can set up, but you end up dividing by that scale factor, and the same dividing by that scale factor is the same as multiplying by that denominator. So you would take a measurement on the map and you would end up multiplying it, in this case, by 11,200. Now, you may see on many maps something that I would call a convenience conversion. And what does that look like? So a convenience conversion is actually often written as a scale, but it'll look like this. For instance, for this particular map, you can see that 1 centimeter on the map is equivalent to 112 meters in real life. Right? 11,200 centimeters is 112 meters. So this will often appear at some point on the map. And it is very convenient because now you can just measure off centimeters and know that every centimeter is 112 meters. But this is not a scale. A scale doesn't have any units whatsoever. the 1 to 11,200, we can apply whatever unit we like. If we only have a ruler with inches, we can say, well, 1 inch on that map is equivalent to 11,200 inches. Using imperial measures, you usually have to pull out a calculator to actually figure out what that means. 11,200 inches isn't really something that's easy to calculate in our head. You know, it's obviously a little bit less than 1,000 feet. But other than that, we can't really do a nice conversion, whereas metric, it's pretty easy to do the conversion. Now, let's do something just like that. So you can see right just to the left of the center of the image there in the map, there's a blue oval, which is the track, running track. And you know, let's say we pulled out a ruler and we measured the track there where it says Kerrisdale Park. So let's say the measurement from one outer edge of that blue track right down to the bottom, so we're measuring sort of top to bottom, that track ends up being 1.56 centimeters. Now I'd have to have a pretty good ruler to do this, but let's just imagine I do. So how am I going to figure out how far that is in real life? Well, I told you a minute ago that, you know, you're going to end up multiplying by 11,200. But what's the actual equation that we're solving to get that? Well, remember, it looks like this. The length of the object, or the real life, in this case, the reality. So the real length we can multiply by the scale factor, which is 1 over 11,200, and that gives us the length of the image, which I have just told you is 1.56 centimeters. And so if I multiply both sides of that equation by 11,200, I get the real length is equal to 1.56 centimeters times 11,200, and that turns out to be about 175 meters. It comes out to 174. Well, 100, initially it's going to be in centimeters, so it's going to be 17,472 centimeters. And if I convert that into meters, I get 174.72 centimeters. And using the tool on Google Maps, it certainly looks like it's roughly around 175 meters. So that gives you a pretty nice estimate. Now, you may also see another type of conversion factor, or a conversion image, if you like, on some maps. And again, it's a convenience conversion. It's going to look something like this. You might have part of this sort of shaded in like this, and you have 0, 100, 200, 300, 400, let's say 500 kilometers. So, this would be a much smaller scale, right? A much bigger reduction. But again, this is not a scale. This is more of a convenience factor. These black and white alternating maybe 1 centimeter, and so what we're saying here is 1 centimeter is equivalent to 100 kilometers. But what would the actual scale factor be in that case? Well, the scale factor would be 1 centimeter over 100 kilometers. But we can't simply leave it like that because the units aren't the same. So we could convert 100 kilometers first to meters by multiplying by 1,000, so you'd get 100,000. And then we'd still have to go a little further, converting the 100,000 to multiply that by 100 and get 10 million centimeters. And so our at this point now, the centimeters will cancel out, and we'll have a scale factor that has no units whatsoever, which is simply 1 over 10 million. And our scale, which you would commonly see on a map, expressed in ratio form, would be 1 to 10 million. And so again, we can use that with whatever, whatever unit we like. We can say that 1 millimeter, as measured on our map, is equivalent to 10 million millimeters. and 10 million millimeters is the same as 10 kilometers. But we could just as easily say, well, 1 inch on the map is the same as, and we shouldn't really say an equals here, it should be sort of equivalent to 10 million inches. Now, I have no idea how long 10 million inches without pulling out a calculator, but I can pull out my calculator and find out that 10 million inches is approximately 157.8 miles. And so we can use the scale with whatever units we like, and in that way it doesn't matter what measurement device we have.